Hello, everyone. Welcome onto this class. The focus of today's class is to show you how you can run independent sum multi-test in R Studio. So you want to leverage on R Studio to run independent sum multi-test analysis. Let's look at the data set we will be using for this analysis. Now, this is the scores recorded by a teacher. This is the performance of the student in mathematics. You can see math scores. And we have, so this is the dependent variable. So your dependent variable should be measured on continuous level of measurement. Now this is our independent variable, that is gender. So in other words, what the teacher wants to see, what is the performance? Want to see the performance of the student in two levels. In other words, looking at the gender, you want to look at whether the female student perform better than the male student, or male student perform better than the female student, because the findings from the study is going to help his teaching methodology. Maybe he has to focus more on the boys, or she has to, of course, normally the teacher should not be skewed. So this is the data set we'll be using for this analysis, and we'll be making use of her. So now what we have to do, we have to yes, launch the R Studio software. So this is R Studio, and if you follow the video, so one of the things you have to do first, number one, you have to install the necessary packages. Number two, you have to load the libraries after the installations. And you look at, so I've already arranged the packages and the code that we need. You can also make use of the code if you want to practice with it. So when you see it, if you have not installed any of it, when you see it, what you have to do, you click run, because I've already done that. I don't have to repeat the process. Yes, so you can see this is for reading Excel file. You can see ggplot for visualization. So if you just put your cursor, you can see how the where the cursor is. Just click on run. That's all you have to do. For statistical plot, this is for data manipulation. This is for checking variance. That is Levene test, and this is for effect site. So the first step is you have to install the necessary application, the packages. The first step, you have to install the necessary packages, and I've shown you how you can do that. As a cursor is moving, just click run. The RStudio will install the necessary packages, and not just necessary packages. There's packages that have file outline here. So as you click run, it's going to run each as you instruct the software to run. So after that, you load the necessary. So you load it. That's package. Each of those packages. So this is this package is to read exe file, which is very, very important to read exe file. So what you have to do, to click on run and take note of the learning process. You can see the code also, library reader. So and you can run all the, you can load all the library at once, so that at every stage you don't have to come back, and so you run it. So that's what I'm doing. Car for effect size. That is when the result is significant. You have to determine the effect size. That's the hexes. So that is okay. No, this is leveling. This is leveling tests, checking the assumption of the data of equal variance. And this is effect size. This is the last one. So after that, so we have to now start the process. Now take note of the working directory. That's where you yes, ensure that the file, the data set you want to make use of, and the working directory is very, very important. And so you have to set the working directory. For me, I need to set a working directory. Set working directory, shoot directory. I want to shoot a directory. This is my directory. This is okay, desktop. This is working directory. So I've done that. So you set the working directory. And the exact data set I show you at the beginning of the training is stored in the working directory. So we can continue now. So we want to read the exe file. So this is the data, and sp in mass, that's the name of the data. set. So you have to take note of the data set, which is very, very important. And you are instructing our studio to read the Excel, the Excel file. So all you have to do, run, and they want to view the first few rows of the data set. So, and take note of the data. That's what you use to yes, read Excel file. That's what you use in the beginning. So you have to take note. Whatever you use here, very, very important. If you use data set, put data set there. So it's not fees, it's whatever you use it that you continue to use. So head the data. So show me the first few rows of the data. So we can see it. So male, these first few rows, we can see the mass scores, the yes, of each of the respondent is very, very important. You can also check the structure of the data set. So that the structure, you can see the group, you can see the male, you can see that is the structure of the data set. And you can see, check the summary statistics. Oh, sorry. This is for missing values. You can check if there's missing values. So missing value, so you can run. So check for missing value. You can see zero. In other words, there's no missing value. Okay. And the next thing you have to do is convert the group male into a categorical factor. Then don't forget this is it male, female. You want to categorize. If you are using software like SPSS, we ask you. That's where you label male is equal to one, female is equal to two. Of course, it's a nominal variable. You can decide to label female one or male two. It's a nominal variable. In other words, the essence of the number is just to identify the variable, and that's our independent variable, which is gender. Now, so we have to let's move on. And the summary statistic of mass score. So I think, oh, okay, this is where we are to convert the group to a categorical factor. We've done that. Let's find the summary statistic of the mass score. So we can see that the minimum, that's the minimum performance, that's maximum performance, that's the median, and that is the mean. You can see the difference between the median and median. That's one, first quarter, third quarter, so that's a summary statistics. And we can also check count of male, how many males, how many females do we have in data set. We have 30 male, 30 female. It's not a must have to be equal, but it's just the number of male and female in the data set. Now, we can also report mean and standard deviation by each group. Yes, mean and data set deviation, mean and the mean and standard deviation. You know, it means very, very important. And don't forget, it's independent sample test. Call it comparison of means. We're looking at means of male and means of female, and you want to compare them. So you can run. So we run that, you can print. In other words, let's see the result. You can see the mean is 78.5. That is for female. And for me, in other words, how the male performance in this class in mathematics is 78.5, female performance is 78.5, while the male performance is 73.5. And we can see the standard deviation, and we can see the count number of male, that is here. Now, assumption is very, very important. Yes, and those are the things you have to check, which we also determine if you run independent sample test or its equivalent. So we need to check the normality test. So we have the Shapiro, don't forget it's two groups. So for male, let's see for male that you run it. Or let's also see for female. And you can see this value, the p-value is greater than 0.05. So we can say, so it is not significant. So the test is normally distributed. And we can move on also to test, yes, to test for equal variance. Equal variance. Are the variance equal or not? So let's test for that. So you can run. You can also see that the p-value is greater than 0.05. So go ahead to run independent sample t-test. So now we can go ahead and run independent sample t-test. So what do I have to do? This is the code. So run it. and I can also print to see the result. Now this is the result. You can see it. Oh, mean in group, mean in group female. That's it. So what's the T 2.07? What's the DF 58? And yes, the total sample is 60, and that is number of sample in group one. That is group one is male, that is 30, plus that of female, that is 30, that is 30. So 30 plus 30, 60 minus 2, that is 58. That is why I have this 58, and the p-value says 0.04. So we can see that this is less than the p. You can say that it's less than 0.05 level of significance. In other words, the significant difference between the performance of female and male students in mathematics. And the question is, who performed better? That's the next question. And we can see that since the female has the highest mean, so the female student perform better than male students, and that's a finding. So the teacher can make use of this finding, yes, to modify his teaching methodology and see what he can do to assist the male, so that of course both parties, of course, that's a revelation. It could be maybe more the males are more serious than just it to the council. It's not just that the teacher is not teaching well. It could be that the male just need to study more, maybe. Yes, so it also help in the counseling service for the teachers as towards the male student. So there are a lot of information, a lot of decision the teacher can take based on this result. So this is how to run independent and multi-test. And you also want to look at you want to look at the effect of the significance. So that is effect size. And what do you have to do? Let's check. Let's run for the males. That's the first thing. Check. That is for. Let's also run for female also. So that's for female. So let's check. Let's check. Length male. That's 30. Okay, that's good. We are checking if the extraction work, which it worked. Oh, the same thing for female. So we can now decide to run for the coins. Yes, that is coins D. And we can see the coins D was in. That is 0.53. Yes, 0.53. So this is very, very important. And in the list, in the table value of the coins D, we have, if it's less than, maybe around that zero point 0.2, that is a small effect. If what we have is 0. Maybe going to 0.5, that's medium effect. And we'll see our result is moderate effect. If it's higher than that, like 0.8 to 0. That's large effect. So what we have here is 0.5, that is medium effect. So what can we say about the interpretation is that the difference in scores between male and female is moderate, not so huge, but it's still meaningful. So female moderately they perform better than male students in mathematics. In mathematics, other subjects can have different maybe scores, but this is for mathematics. And before we round up, you can also determine, maybe you can decide to for the visualization. Maybe you want to visualize the scores in the bus plot and the likes. If you want to do that, you can make use of this code to achieve that. That's for bus plot. You can see it for the bus plots. And this is for female. This is for male. Yes, you can see it. And you can see like this average. That is a median value. Median value. The number that's median value is very, very important. So this also you can make sure this visualization. We also decide to check for density plot. Density plot. Yes, that's density plot also. Or run also, that's what density plot. You can also see. So this is how to use R Studio to run analysis, independent sample t-tests. So I've explained this video. So if you are yet to subscribe to this channel, kindly the subscribe button and also click on the bell to get alert for subsequent uploads. Thank you for watching.